Hi guys, so today I am gonna do a video on both week 6 slides as well as week 7. So I'm sorry for the delay, but I figured I would just combine the two together, and this will also be a great review for the exam that's coming up. So I'm just gonna do a quick review of arrays, even though I know we have a video on arrays already. So an array is just an index list of values. You can make an array of any type of object or primitive data type in Java, but once you've decided what type is going to be stored in the array, you can never change it. And all elements of the array have to have the same type. So if you create an array of integers, then every other element in the array also has to be an integer. Again, if you create an array of type string, which is an object, then every other element in the array has to be a string as well. When you're initializing an array, there are two ways to do it. So the first way, which you can see at the very top here, is just to declare the type and to declare the size of the array. And you do that by saying the type of the array, square brackets, the name you decide to give your array. This is all on the left side of the equal sign, and then on the right side of the equal sign you have new, which is a special keyword in Java that tells Java, hey, allocate some space in memory for whatever variable I'm creating right now. So in this case, it's allocating some space for an array made up of type doubles, and we're indicating that this array will have 5 elements in it. Hence, on the right side, we have new, the type again, and the length. As in the example, it's 5. So that's the first way to initialize an array. The second way of initializing an array is to directly tell what the values of the array are going to be on the right side. And so we do that with curly brackets to distinguish them from the square brackets, and we give the specific value in a single line. So this is great if you're creating small arrays, but in general when you're creating arrays that are really big and you can't initialize all the values right at the beginning, then it's better to do the first way of initializing, where you just specify the type and the length. So when you do the first way of initializing, there's some default values given because you're not telling the exact values. Java just gives the array default values. And so in the case of integers, the value is 0. In the case of double, it's 0.0. For the type Boolean, it's false. So you can see that's all on the false or 0 side. And then for any type of object, like strings or any other non-primitive type, Java defaults to the value null, N-U-L-L. This is a value in Java to represent nothing, to actually represent like no actual being, null. Yeah, so that's how you initialize an array, and those are the default values depending on the type of array you create. So when you have to try and find the size of an array, you use the parameter length. So every array has a length variable built in that keeps track of how big the array is. And this value of length is set when you initialize the array. So in this case, in these two examples, you can see that in both cases, when you initialize the array, you already know what the size of the array is. And so when you try to get the array values.length, it will tell you how many elements are in the array. So if you ever need to find the size of an array, use the parameter length. If you need to get an element outside of an array, you use the square brackets and you give the index of the element that you're looking for. So in this case, in the example here, we can see that we've declared an array value. So declaring something is everything that happens on the left side of the equal sign. It's when you give it a type and when you give it a variable name. Initializing is when you give a variable its value for the first time. Every time that you give a variable a value after that, it's called assigning a variable a value. So the 3 keywords here to remember are declaring a variable, initializing a variable, and then assigning a value to a variable. So in this case, in the first line, we have this array values. It is of type int, and it has 5 values in it. And it's being initialized with those 5 values immediately. Then in order for us to return, to change the value at a specific array, a specific spot in the array, then we find the index whose value we want to replace, and we say values at index 3, I want the value to be equal to 18. So again, like everything in Java, value, indexing in Java begins with 0. So the first element is at spot 0. The second element is at spot 1. The third element is at spot 2. And then the fourth element is at spot 3. So what this line is doing is it's changing the value of the element in the fourth spot to be 18. And then in the next line, we're setting the spot, we're setting x to be equal to values 1. So the whatever value is at index 1 in the array values. So at index 0 we have 12, at index 1 we have 24. We're adding 3 to 24 and setting that equal to be the value of x. The value of x after this line is executed will be 27. So when you're getting or setting values in an array, all you have to do is call the array name, and then in the square brackets, give the index that you're interested in. So in general, whenever you have arrays and you need to traverse every value inside of the array, you're going to combine it with a loop. So that was covered in more detail last week, but in general, whenever you have to do anything more than once, you should be using a loop. And in the case of arrays, when you have to try and access every value or sum up all the values or print out any values, you'll be using a loop as well. So here are 6 examples of different things that you can do with an array and a loop. Let me know if you have any specific questions about any of these methods. Specifically, we can just look at the first one though, what it's doing, creating an array with random values. The first line is declaring an array of type double named A, and it's saying it's a new array of type double and it has some size n. So then the loop, what it's doing is it's starting from index 0, because everything in Java starts at index 0, and it's going all the way up to but not equal to n, and every time it is setting the value in array A at index I, so starting from 0 all the way up to n-1, which is the last element in the array, it's setting it to be some random value, math.random, which is math is a library in the Java class, and random is a method of that library that just returns a random value. So every time you have to do something with a different value in an array, you're probably going to be combining the array with a loop, as you can see in all 6 of these examples. Okay. So let's just do a quick exercise together. What values does the following code put in the array A? So we can see that this array, so n has a size of 10. This array is now going to be an array of type int and having size 10. Its first element will be at index 0. Its last element will be at index 9. These next 2 lines are setting the next 2 values to be equal to 1. The first 2 values of the array to be equal to 1. And then starting from index 2 and going up to n-1, this array is changing the value of every every subsequent value in A. And it's changing it to be equal to the sum of the 2 elements that came before it. As you can see, A of I is now going to be equal to the sum between AI-1 and AI-2. So it's taking the index is 2 before the current index that we're looking at, and it's adding them together and setting the new value to be what it is at its current spot. So so I didn't actually have a slide drawing this out, and I'm sorry for that, but this is the Fibonacci sequence. And so what this array, what this will look like, and actually, sorry, I don't have a slide for it, so I'm going to add it right now. So I just created a array, right, and I'm representing with this table. And so the third line of code set the value at index 0 to be 1. Then it set the index to be, to set the value at index 1 to be 1 as well. And then we can see that every value after that is the sum of the 2 previous values. So when I is equal to 2, so this is that spot that we're looking at, 0, 1, 2, at index 2, we're setting its value to be equal to whatever the value is at index 1 plus whatever the value is at index 0. So that's 1 plus 1, which is 2. Then we go to I is equal to 3, so we move into the 4th spot, and then at A of 3, we can see that the value is going to be equal to the value at A at index 2 plus the value of A at index 1. So that's 2 plus 1, which is 3. We can see a pattern here, so I move on to the next spot. This will be equal to 5, and then 8, and then 13, and then 21, and then finally sorry. Okay, so now we see this code, and then if I draw out the array, we would see the following. So this was just a walkthrough through the sample code. You can also plug it in into Eclipse and see how it works out. Okay, so that was my quick review of arrays, and now I'm going to move on to ArrayLists. So this is a new topic that we covered last week, and ArrayLists are probably what you're going to be using more often than arrays. Arrays came first as a construct of Java, but then ArrayLists came later because they're more efficient and flexible. So consider the following task. You have this problem where you are a teacher like me, or you're dealing with grades in some way. So you're reading in double values representing grades until the user enters a negative number. Then for all of the non-negative values entered, you're computing the average, the maximum, the minimum, the number of grades that are above the average, and the number of grades that are below the average, and of course the median grade. So if you knew how many grades there were going to be total, you could just use an array. But in this case, because you're using scanner and you're going until the user enters a negative number, you have no idea how many grades the user will enter. So we just have to keep keeping track of more and more grades. So an array requires you to know how big the array needs to be before you even make it. So what we could do is create an array that's huge. We could create an array of 1,000 elements, but because we know that there will be definitely less than 1,000 grades. But that's really inefficient. We're putting aside all of the space and memory just because we don't actually know. And so there has to be a more flexible way to do the same things that an array does, but have it change size. And so that's why we have ArrayLists. ArrayLists are dynamically changing sized arrays. So that means an ArrayList can add more elements or remove elements without any concern about the size it was originally. So some of the basic functionality that comes with a standard array also comes with an array list. It is an ordered collection of values. So every value in the array list is at a specific index. The index, of course, starts at 0, like everything in Java, and it ends at n-1 if there are n elements in the array list. The advantage of an array list, however, is that it grows or shrinks based off how many elements you add or delete from it. So how to create an array list? So an array list is not native to Java like arrays. So you have to import a library. You import java.util.ArrayList, and you have to do this at the top of your file. And the array list is a class that is part of Java standard library. So it's just like scanner. So you can also just import java.util.star, which imports every library within the util package. So when you have an array list, there's only one way to initialize it. So unlike an array, you specify the object type that's going to be in the array list, you give it a name, and you say new array list. Again, you use the keyword new because it's Java's special keyword to allocate space in memory. So everything to the left side is declaring the array list, everything to the right is initializing it for the first time. Here you can see that there are two parentheses. It's because this line of code on the right, new array list parentheses, is initializing, it's calling a special method of the ArrayList class. In fact, every time we have something new and a method call, after that, it's calling a special type of method in every class called a constructor. And we'll talk about constructors more after the next exam. But just so that you know, that's what it's doing here. But unimportant for the exam, all you need to know for the exam is how to declare an array list and how to initialize it. Here are some of the big things that are the differences between arrays and array lists. So arrays are fixed at creation. They, when you're trying to get a value from an array, you use the array name and use square brackets and the index that you're interested in. When you're creating an array, you say new, the type, and then the size of the array. And if you need to get the size of an array, you say grades.length. This is pretty different from array lists in that array lists are flexible. They can get bigger, they can get smaller, whatever you want. When you're getting an array or whenever you're getting an element from an array or getting the size or doing anything really with arrays, you use methods instead of directly accessing elements. And so here you can see that you have array is the array name .get. So grades.get or grades.size. You always use methods to access any of the elements inside of an array list. This is confusing, but when you get a size of an array, you use the parameter length. When you get the size of an array list, you use the method size. And then we're going to talk about how to get the size of a string, and that will add a third level of confusion. But it's important to be able to distinguish what you use for arrays versus array lists. Okay. So here we can see the different ways of constructing, storing a value, and retrieving a value from an array versus an array list. So here we have an array called names. We declare it as type string, and we're indicating initially how big the array will be. So here's size 5, whereas with an array list, we don't have to do that. We can just say it's going to hold type string, and it can be any size that it wants. Then when you're storing a value, use square brackets with an array. However, with an array list, use a method called add. And then when you're getting a value from an array, again, use square brackets and the index, but in an array list, use a method called get. So in arrays, you can directly access the elements. With array lists, you have to use methods to access the different parts of an array list. So when you declare or create an array list, you should always specify the element in the angle brackets, but you don't actually have to. You can use really generic types with array lists. So you could create an array list of objects and then put in strings and integers and characters all into an array list. An array list doesn't have to be of the same object type. So that's another advantage of array lists. In general, array lists can only hold objects. They cannot hold primitive data types. So we've talked about this, talked about primitive data types. So there are 8 primitive data types in Java: Boolean, byte, char, double, float, int, long, and short. So arrays can hold primitive data types and objects, but array lists can only hold objects. This is a restriction of the array list data structure. And so what Java does to get around this problem is it has created a wrapper class that for each primitive data type, so that converts that primitive data type into an object type. And so for your purposes, the main difference is that you use a capital letter for the primitive data type, except for the case of char and int. So char and int are obviously short for character and integer, so their wrapper classes are character and integer instead of char and int. But everything else is just taking the name and giving it a capital first letter. And that indicates that it's the wrapper class instead of the primitive data type. But just in general, it's important to know that you cannot create an array list of ints. You have to create an array list of integers. So that's a restriction on array lists. The way that wrapper classes work is through a concept of boxing and unboxing in Java. So this is not something that's super important, especially in an Intro to Java class, but I wanted you guys to be aware of this concept. So wrapper classes used to be much harder to use than they are today. Recent versions of Java include this procedure of boxing and unboxing that automatically converts between a primitive data type and the corresponding wrapper class. So if an array list is made up of integers and you say int answer is equal to an integer object, Java automatically converts that integer object into an int, the primitive data type. So Java does this automatically in the backend, and so this is not something that you need to be aware of how it works, but it is good to know that Java does go through this process of converting the wrapper class to primitive data types and the process of converting a primitive data type into a wrapper class object. So that process is called boxing and unboxing. Again, not super important, but good for context. So here's an example of an array list. Here we have array list of type string. It's called myR. It's new array list, and then this array list adds the Italian. Oops, I noticed this wasn't on separate lines. So this array list is then adding the word Italian Riviera to it, then the Jersey Shore, and then Puerto Rico. So array lists can hold elements of different sizes, but in this case, this array list is specified that it's only going to be holding types of type string. To check the size of this array, you would use the method .size, and so in this case, my r.size would return 3. Okay, so which of the following statements is not true about array lists? Array lists are slightly faster than arrays. Array lists can store elements of different types. Array lists can increase in size to store more elements. Array lists have methods to manage their content. So we know that array lists can store elements of different sizes. We know that array lists can increase in size to store more elements, and they can also decrease in size to store fewer elements. Those are one of the big advantages over arrays. Array lists have methods to manage their content. We know that is true as well. Arrays, we have to directly access elements using square brackets, but with an array list, we use methods like add, get, put. So by process of elimination, we know that array lists are not faster than arrays. Given the following code fragment where this array list, my array list, is getting declared and initialized, then the next lines are adding strings 1, 2, 3, and 4 to the array list. So the question is asking which of the following lines of code will modify my array list so it looks like 1, 2, 4. So in general, it's asking to remove the element located at index 2 or the string 3. So how do we know 3 is at index 2? Because again, everything Java starts with index 0. So 1 is located at index 0, 2 is located at index 1, the string 3 is located at index 2, and the string 4 is located at index 3. So we're either removing index 2 or we're removing the string 3. So the first line of code, A, myArrayList.remove myArrayList.get3 will remove the string 4 because myArrayList.get3 returns the string at index 3, which is 4, and then myArrayList.remove will then look for the string 4 and remove it. So A does not work correctly. B is saying myArrayList.remove myArrayList.index of 3. So what is this doing? It's finding the index of the string 3, which is 2, and then it's removing whatever is in the array list at index 2, which is the string 3. So B does work. C is directly removing the string by saying myArrayList.remove string 3. And then D, so that works as well. And then D is doing myArrayList.remove myArrayList.getTo. So what it's going to do is it's going to get what is in the array list at index 2, which is the string 3, and then remove it. So all B, C, and D all work. A is the only one that does not. Okay, so the methods of the ArrayList class. We have Boolean add, where you can add an object, and this always returns true because unless there's an error. Then you have the add method. So this add method takes in a specific index and a specific object, and it adds it at that specific index. You can also, so you can see here that there are two add methods. So one where we specify which index to add it at, and one where we say just add it to the array list. Then you have the method get, which returns the index at returns the object at index I, index of, which returns whether the object exists in the array list, and it returns -1 if it's not found. Otherwise, it returns the actual index. We have isEmpty to check if an array list has objects or not. Remove, either to remove something at a specific index, or remove to remove something to remove a specific object. If we want to change the value at a specific index, then we have to use the method set. So it's unlike add, which adds something to that index and then shifts everything to the right. So you're increasing the size of an array by 1 when you add. Set does not change the size of the array at all. It changes what is at that index to be a new value. And finally, we have the method size that returns the full size of the array list. So going back to the problem, we want code that reads in text one line at a time until the user enters the word stop. Then the code should repeat back all of the lines in reverse order. We don't know how many lines of text there will be before the start. So what's the best way to do this? With an array list. So first thing with array lists, we have to import the package and the library for ArrayLists. So we do that by import java.util.ArrayList. Then we have our main method, and inside of our main method, we create an array list, string list, and we create a scanner object keyboard. Then we have my input text, and I say, while my input is not equal to stop, please keep taking in input from the user. And then taking in that input from the user, add it to my array list string list, where I'm keeping track of all of the inputs from the user. Then, starting with an index of n-1, where n represents the size of my array list, or actually in this case I have I, while I is greater than 0, go backwards through the array list and print out what is at that point, at that index in the array list. So here stringlist.get I gets what is in the array list at index I, and because I is starting from the end of the array list, instead of starting at 0, it's going to go backwards, and then I'm decrementing I every time until we get to I equals 0, which means we have printed out the first item in the array list, and ta-da! We print out backwards the input of everything that the user gave us using array lists. This is something that we could not have done with an array because we have no idea how many times the user is going to have us add strings to our data structure. I hope that's helpful. I go through this code in more detail using some slides. So import, declaring the array, the methods, add, get, size, set, and add. So I went over this quickly before. You can look at that for more detail. I will post these slides. Here is the next exercise, writing a segment of code that takes in an array list of strings named list and removes any strings that are longer than 5 characters. So here I have the first exercise. So I see a typo, so let me just fix that. So we already are given a list of strings here called list. And so what this is going to do is it's going to go from I equals 0 to while I is less than list dot length size, because it's an array list. Okay, so what this is going to do is it's going to start at I equals 0, and it is going to check for every index I, which is less than the size of the list. It's going to get the string at that index. It's going to check if the string's character length is greater than 5, and if it is, it's going to remove it from the array list. And then it's going to increment the index of I. So this is the code that I've written out. Take a second to think if this actually works. Does this code look right? So here, clearly this is a trick question, because why would I be asking you if this works or not if I fully agreed that it did work? The problem line here is list.remove. So when you're removing elements from a list, you have to be careful. When you add something to an array, you're at a specific index, then everything shifts down. You're changing the array's size by adding 1. When you remove something from an array list, everything shifts to the left. And this time, you're actually reducing the size of the array list by 1. And so if you imagine the array list like this, and we're looking at every string, and you remove index 6 because the string at index 6 is greater than 5 characters, and you increment I, so you're suddenly looking at spot index 7 now, you will end up skipping the actual string at index 7 because you incremented I while also removing something from the list. And so if we went back to fix this code, the way that we would fix this code is say either we remove something from the list or by using else, else we're going to increment I. But we can't do both. We can't increment I and remove the element because then we would be skipping a spot in the array. So this is just something you have to be careful about when you're removing elements from a list and you're incrementing things at the same time. When you're traversing through the array list, every time you remove an element, you have to recheck that index because everything shifted to the left. As seen in this image. Okay, if you have questions about that, please post on the discussion forum. But that is all I have to say about array lists. And so now I'm going to move on to strings. So strings are not a primitive type. We've been using strings to communicate with the user, hello world, but in general, they're an object type. Strings are actually arrays of characters. Every time you create a string, like for example here, hello world, we've created an array of different characters, including all the letters of the alphabet, but also spaces, the comma, the exclamation point. When you put two strings together, we use the plus sign, and we've done that before in this class. But in general, the string class has a method called concat to signify concatenating or joining two strings together. But it's almost never used because we use the plus sign instead. The plus sign is a shortcut in Java for calling the concat method of the string class. Java is special in that when you use numbers with the plus sign, it decides to do math, but whenever you have two elements and one of them is a string, Java interprets the plus sign as concatenation. So if you did hello plus 5, it would convert the 5 to a string and combine the two things together to create a new string, hello 5. So we can see here that using the plus sign adds these two strings together to create a new string, hello world. So whenever you want to try and extract something from a string, you can do it in two ways. You can provide two indexes. where the first index is the position where you want to start your substring, and the second index is the position right after the last thing that you want in your substring. Or you can just specify a single index, and then what the substring method does is it provides the entire fragment of the string starting from that index until the end of the string. So this will be better conveyed with an example. So here we can see if you do string.substring 1, 4 for the original string hello world, this would return the string fragment ELL. Otherwise, you can see if you only provide a single index, then this will go till the end of the string. So if you provide index 7, then string.substring 7 would return world ! Which is the same thing as calling 7, 13. So the string goes from 7 till the last, to the size of the string. So in this case, 13. So whenever you are asked to test whether two strings are equal in the sense that they contain the same characters, you cannot use the double equal signs. So the double equal signs in Java always checks if two characters have the same memory address. So when you want to check if two strings are equal, you have to use the method .equals. So in general, when you're comparing two strings, never use the two equal signs, always use the method .equals. When you're searching a string, there are several different types of methods to search a string. So index of is one of the most common methods used, and we saw that method also in the ArrayLists class. Index of will take in a specific character or a entire string, and it will tell you the initial point of that fragment of a string or the character. So in the case of checking if hello world str, in this case, has an h in it, we can do str.index of h, and it returns 0 because it returns the first occurrence of that character. Again, you can see that same concept demonstrated by the next line of code, str.index of o. O returns 4 because the first O in the string hello world occurs at index 4. So H is at index 0, E is at index 1, L is at index 2, L is again at index 3, and then O comes at index 4. If we specified that we want the search to start at a specific index, so here we can see another way of calling index of, where we do str.index of the character O starting at index 5, then we can see that the actual number returned is now 8 because it doesn't even look at index 4. It starts at index 5, 6, 7, which is W, and then 8, which is the next O. You can also search for actual fragments of strings. So ELL begins at index 1. And then you can also check for characters that don't exist in the string, so in this case X. And if something does not exist in the string, then index of returns -1, which is a common concept in Java. Whenever something's not found, you return -1. Okay, so if you are still confused or you want more practice problems that you can do by yourself, I would recommend going to codingbat.com/Java. It has a ton of exercises that you can practice with, and it has test cases to help run you through them. So for example, if I'm just going to go, let's do a string problem together. So hello name, which sounds pretty simple. It is a problem. Given a string Bob, return a greeting of the form hello Bob. So if hello name is called with the string Bob, it should return hello Bob, or hello Alice, or hello X. Okay, so we have this method, public string hello name string name. So what do we know? So this method is public. It is going to return something of type string. The name of the method is hello name, and this method takes in a single parameter, string name. So if I want to return something using name, I would do system.out.println. I would say hello. I would put a space. I would end my string. I would use the plus sign to concatenate my string with the variable name. I would add another plus sign and add the remaining bit of my string. I would end my system.out.println, and I would add a semicolon. But I just realized that this actually wants me to return the string, not actually print it out. So ignore that. So I'm actually going to get rid of this line by commenting it out. And instead, I'm going to create a new variable, string hello name is equal to the same stuff, semicolon, and then I'm going to return it like this. Now I'm going to compile, and you can see that this site is so great. What it will do is it'll give you some test cases that it's going to try out. It's going to run them and see if your code provides the right answer. So my solution is all correct. I can see their solution, and it's similar to mine. And I can also see hints in case I was confused. So if you want to practice some more with strings, arrays, and some of the other concepts that we've covered in this class, I highly recommend this site. It has some great test cases and some great ways to practice stuff. Cool, that's all I have for you guys today. What we're going to be covering after the exam, so not next week, but after the exam, is going to be recursion. So here's some resources for that. And yeah, that's all I wanted to talk to you guys about today. I hope this video was helpful. Let me know